So what is a function? Quite simply, a function is something that takes in a number, say 3, it goes into the function, which you can kind of think about like a black box, and out comes another number, let's say 4. And so basically you can think about functions as machines that take in an input and give you an output. So let's think of an example. Let's look at an equation which we're going to then turn into a function. So the equation is the ideal gas law that states that the pressure times the volume is equal to the number of moles times the gas constant times the temperature. So what we want to do is we want to rearrange it so that we have pressure as a function of the other variables. So we note that V is a variable, N is a variable, T is a variable, and this is a constant. And so that's an important thing to note. So the first thing we learn about algebra is that if you want to rearrange an equation and move something to another side, you have to do the same thing to both sides. Very important, most important rule of algebra. So let's say I want to move the V onto the right hand side. I'm going to multiply both sides by V, and we see that V divided by V is going to equal 1, because if you have any number divided by itself, it's going to give you 1, because 3 into 3 goes 1 times, or 1 times 3 is 3. So we have P in terms of the other variables, N, R, T, and V. And we say that P is a function of N, T, and V. And that basically helps us to understand this. So let's say now we set the temperature at room temperature, which is 298 Kelvin, and we set the number of moles at 0.01 moles, and we change the volume. So when we put values into here, we basically put them into their corresponding places in the function. So N is going to be 0.01, the gas constant, which is 8.314. We note that I need to put in the units, moles here. The gas constant's joules per mole per Kelvin, and times by T, which is times 298 Kelvin, and divide that by V. And so basically the pressure at these set values at N, T, V varies by some constant out the front here, which we're just going to wrap all this up into a constant. Let's just call that C, divided by V. And what we can say then is that the pressure change is proportional to 1 over V. So that means that if we change P by a small amount, V will change by 1 over that amount. So what that looks like when we plot it, so this is for when N is equal to 0.01 and T is equal to 298 Kelvin, we're going to see this relationship here. So this is pressure here, and then this is volume. And so pressure changes as a function of 1 over V times some sort of constant which we've got. Okay, and the constant just scales this axis here, right? Because for each value along V, it's just going to be multiplied by some constant which is determined by the number of moles and the temperature. And so if we change, for example, the temperature, then what we'll do is we'll actually draw another line which is at a slightly different height. And then you can start to think about an engine, because an engine is basically something that changes the pressure and changes the volume, and so you can start to go in loops like that, and you can start to do work. So this is how engines work, and different engines will have different slopes, and so you can start to see that you can start to think about these different lines. And you'll learn about that in thermodynamics, which is very cool subject. But that sums up everything to do with functions.